In 2023, Texas experienced a total of 223 tornadoes. June was notably the most active month, with a significant tornado outbreak across the US, including Texas. On June 21st, a particularly destructive EF3 tornado hit Matador, Texas, resulting in 4 fatalities and severe damage to homes and infrastructure. This year marked one of the most tornado-active periods in recent history for the state. No AA NCEI. But what exactly is a tornado, and when does an insignificant storm become a supercell? Find out in the new documentary, Tornado, Storms and Supercells.
What's your emergency?
Hey, yeah, hi. I would like to report a big storm. Could be a tornado. I don't know. It's approaching from the south. It is a 20 near Odessa. Looks pretty fast and intense and huge. Do you have any information on this?
You can start for southward.
Officers are on the scene.
10-4.
Supercells are storms, usually, but not necessarily thunderstorms, that contain updrafts that rotate about a vertical axis. This rotation is derived from shear in the environmental wind field, that is, a change in wind direction and chance or speed with height, surrounding the storm as it begins to grow. Supercells often produce damaging wind, large hail, and tornadoes, and most strong to violent tornadoes are associated with supercells. Analogous to cancer cells in a living organism, supercells differ from ordinary thunderstorms in that the rotation of their updraft enables them to overcome the self-limiting mechanisms that bring demise to regular storms. Once formed, a supercell may perpetuate itself for an appreciable length of time, even upon encountering an environment that is hostile to the development of new storms. What ingredients are needed for the development of supercells? Although supercells require some degree of buoyancy, moderate to strong speed and directional wind shear between the surface and about 20,000 feet is the most critical factor. Wind shear not only creates the mesocyclone, but it also allows the storm to be tilted, which is important for maintaining a separate updraft and downdraft region. A separate updraft and downdraft allows the supercell to be long-lived because it reduces the likelihood that too much rain-cooled, stable air from the downdraft region will be ingested into the updraft, causing the storm to weaken. We have already learned how a supercell forms and that tornadoes can develop from it. However, not every supercell becomes a tornado. So what is needed for a tornado to form? For a tornado to form, there also needs to be spinning air near the ground. This happens when air in the storm sinks to the ground and spreads out across it in gusts. Gusts of warmer air rise and gusts of cooler air sink as they blow across the land. If there are enough rising and sinking gusts, the air near the ground starts spinning. The spinning air near the ground speeds up as it is drawn inward toward its axis of rotation. This happens in the same way that figure skaters spin faster when their arms are drawn in, rather than when their arms are outstretched. This is called conservation of angular momentum. The rotating air moves horizontally across the ground and can be tilted vertically by the force of the rising, rotating air. This allows a tornado to form. Most tornadoes form during supercell thunderstorms, but not all supercell thunderstorms produce tornadoes. Usually the rotating air near the ground doesn't rotate fast enough for a tornado to form. If the rotating air near the ground is very cold, it will spread away from the storm along the ground and slow down like a figure skater with extended arms, and a tornado will not form. Tornadoes, also called twisters, are columns of air rotating dangerously fast. The air is in motion because of the difference in pressure between the center of the tornado, very low pressure, and the outer edge of the tornado, high pressure. Some tornadoes are quite narrow, only 75 meters, 250 feet, across where they touch the ground. Other, much more massive tornadoes can be up to 2 miles across. Often a tornado will touch the ground for only a few minutes and travel less than a mile. But some tornadoes touch down for much longer, plowing through towns, neighborhoods, or farms. After a tornado has come and gone, scientists look at the amount of damage that it caused to figure out the strength of the twister. They use the enhanced Fujita, EF, scale, 6 categories that describe how tornado damage relates to wind speeds. According to the scale, EF0 is the weakest tornado category with gusts up to 85 miles per hour, 135 km per hour. And EF5 is the strongest tornado with wind gusts over 200 miles per hour, 320 km per hour. In general, tornadoes fall into 3 types: weak tornadoes, strong tornadoes, and violent tornadoes. A tornado's type is based on its size, how long it lasts, and how much damage it causes. Weak tornadoes usually last less than 10 minutes, have winds less than 100 miles per hour, 160 km per hour, and cause damage such as broken tree branches and damaged roofs. Over 2/3 of all tornadoes are weak. Weak tornadoes include those in the first 2 categories of the enhanced Fujita scale, EF0 and EF1. Strong tornadoes can last 20 minutes or longer and have winds of 110 to 205 miles per hour, 177 to 330 km per hour, strong enough to demolish mobile homes and overturn trains. Nearly 1/3 of tornadoes are strong, and they cause nearly 1/3 of all tornado-related deaths. Strong tornadoes include those in the next 2 categories of the enhanced Fujita scale, EF2 and EF3. Violent tornadoes can last over an hour and have wind speeds greater than 205 miles per hour, 330 km per hour. These monster tornadoes can toss cars and houses into the air and carry them for miles. While violent tornadoes are the least common, they are the deadliest, causing over 2/3 of all tornado-related deaths. A violent tornado is part of the last 2 categories on the enhanced Fujita scale, EF4 and EF5. Number 1. The deadliest tornado in history. The deadliest tornado on record occurred in Bangladesh on April 26, 1989, killing approximately 1,300 people. Number 2. The widest tornado ever recorded. The widest tornado ever recorded occurred in El Reno, Oklahoma on May 31, 2013. It reached a width of 2.6 miles, 4.2 kilometers. Number 3. Tornadoes occur on every continent except Antarctica. While the United States experiences the most tornadoes, they can occur anywhere in the world except Antarctica due to its cold climate. Number 4. The most tornadoes in a single day. The United States experienced the most tornadoes in a single day on April 27, 2011, with a total of 218 tornadoes touching down. Number 5. On March 18, 1925, a tornado began its path of destruction in southeastern Missouri through the south of Illinois and Indiana. It covered 219 miles, 352 kilometers, in 3 hours, according to the National Weather Service. It killed nearly 700 people and is considered the longest-lasting tornado on record. No matter how much we advance and how significant the progress in meteorology may be, nature will always be superior to us. We have explored the development of a simple storm into a tornado and gained an understanding of the different categories of the Fujita scale. Thank you for watching this documentary on tornadoes, and I hope you'll join us on our next exciting journey. By the way, do you know the difference between a tornado and a hurricane? Tornadoes always form on land, while hurricanes originate over the ocean and lose strength once they make landfall.